Our next unit is all about functions. We're going to start off by looking at graphing from a t-table, which should be very familiar to you, but there are a lot of connections that students tend to forget that I want to remind you of, as well as intercepts, which is where a graph crosses the x or y axis. Graphing from a t-chart, what you want to do is pick about 5 points to substitute into the equation to get your y value, and then we'll plot those as ordered pairs. Starting off by substituting -2 into the function, we will square it. Be sure that you use parentheses, especially with those negative values. Because order of operations, we need to square the negative. -3 times -2 is a +6, so our y value at -2 is 10. Doing the same thing with our -1, substituting that in, squaring it, -3 times -1. We get 1 squared plus 3, or 4. When we put 0 into the function, 0 squared minus 0 is still 0. If we put 1 into the function, we get 1 squared minus 3 times 1, which gives us 1 minus 3, or -2. And finally, substituting 2, we get 4 minus 6, or -2 again. Graphing these points, we had -2, 10, -1, 4, 0, 0, 1, -2, and 2, -2. Now, if we didn't know what this function looked like on a graph, it might be kind of challenging to figure out based on the points that we picked. However, hopefully you guys recognize that this is a quadratic function, so we will have a parabola, and we can tell that the vertex ended up between 1 and 2. Remember that line of symmetry that goes through a parabola, and you can reflect points across that line of symmetry. So to get a more accurately graphed parabola, we can flip each of those values we already had across the line of symmetry. And make sure when you're drawing your parabolas you get a nice smooth curve. We don't know exactly where the vertex is, so I just made a rounded minimum between my two values. And let's take a look at intercepts. Intercepts is where the graph crosses the x or y axis. I'm going to go back to our graph on the previous page for a second and show you where the intercepts occur on our graph. This is a y as well as an x-intercept, 0, 0, and this is an x-intercept at 3, 0. So no matter where you are along the x-axis, your y value will always be 0. So to solve for an x-intercept, you substitute 0 for y. For the y-intercept, anywhere along the y-axis, your x value is 0. So we'll substitute 0 for x and solve for y. Our first equation, let's find that y-intercept first. Substituting 0 for x, we get 0 minus 0, which is 0. So our y-intercept was, we substituted 0 for x, solved and got 0 for y. Our x-intercept is when we replace y with 0. To solve this one, I'm going to factor. It has a GCF of x, leaving me with x squared minus 4. Now I have a difference of squares, which is x plus 2, x minus 2. And setting each piece equal to 0. I get x equals 0. I get x equals -2. And I get x equals +2. So this one has 3 x-intercepts. We already had the x-intercept of 0, 0 from our y-intercept as well. And now we have -2, 0, and 2, 0 as well for our other x-intercepts. When you solve for an x or y-intercept, make sure that you write your answer as an ordered pair so that you can make that connection between the intercept and the graph versus just solving an equation and saying x equals or y equals. The other thing we need to know about intercepts is that a function can only cross the y-axis once, but it can cross the x-axis multiple times. If you remember learning about the vertical line test, the y-axis is a vertical line. If a graph crossed the y-axis more than once, it would not be a function, which is why we typically only get one y-intercept. And taking a look at our second example, solving for the y-intercept, we're going to substitute 0 for x. So we have y squared equals 4. Now because we're solving this and we are taking the square root of both sides, we have to put that plus or minus on the square root of 4. So we have two y-intercepts on this one. We got 0 for x and a negative 2 for y. We also got 0 for x and a positive 2 for y. That means that this graph would not be a function because it crossed the y-axis twice. Solving for the x-intercept, we substitute 0 for y and solve for x. Squaring 0, of course, is still 0. And subtracting 4 from both sides, we get x equals negative 4. So our x-intercept we solved and got negative 4 for x when we substituted 0 for y. You have two you-try questions. The connection that I want you to make with that t-chart is that every single point on the graph comes from a solution to the equation that you were given. So there's a relationship between the equation, the graph, and the ordered pairs that are solutions or make the equation true. And our second you-try solving for those intercepts.